Congratulations, you've made it to video, I believe, 5 of our look at the blood system, cardiovascular system. And in this video, we're just going to kind of wrap everything up into a nice, neat little package and kind of put the cherry on top with what exactly does how does the autonomic nervous system really regulate this whole blood pressure thing that we've been looking at all week, and how do the arteries and the veins and even the heart know when to change its parameters to increase blood pressure or to decrease blood pressure or to maintain the blood pressure that it is experiencing. And so the first thing that we need to understand about blood pressure regulation is that it is a negative feedback system, right? As is almost the case with all of our organ systems. There is some kind of aspect of negative feedback that is there with it. With cardiovascular negative feedback, more specifically in the regulation of blood pressure, what we see is within the arterioles, within the aorta, within the common carotid, and that's what you're looking at right here. Here you're looking at the common carotid. So here's the common carotid. This here would be the internal carotid. This would be the external carotid that you're looking at right here. And so this is right before that common carotid branches off. There's a little bulge within the common carotid. And within that common carotid is where we have Barore receptors. Now, these Barore receptors measure pressure. Right? Think of barometric. Right? So the Barore receptors are constantly measuring pressure within the blood. And again, it's doing this in a couple points, mainly within the common carotid that you're looking at right here, and within the aorta, are the two main players as far as regulating negative feedback within cardiovascular system. And so within this carotid sinus, there is a network of nerves that are, or receptors that are constantly monitoring blood pressure. And every time a pulse goes by that carotid sinus, those Barore receptors fire off signals to the brainstem, more specifically to the medulla oblongata. And so within the medulla oblongata, there is a specialized region known as the Medullary Cardiovascular Control Center, or what we call the MCCC. And the MCCC, the Medullary Cardiovascular Control Center, is responsible for interpreting the frequency and the intensity of the action potentials being sent by the Barore receptors within that carotid sinus of the common carotid artery. And based off of the information that it is receiving, it in turn stimulates the autonomic nervous system to either increase or decrease or maintain cardiovascular function. Again, this is a continual process. Right? This is a continual process. And so it's not like it will only fire if the blood pressure drops too low, or it's not like it only fires if the blood pressure gets too high. Every time a pulse flows by those Barore receptors within that carotid sinus, it fires, those Barore receptors fire off an action potential to go ahead and communicate with the Medullary Cardiovascular Control Center. All right, and so that's what you're seeing here. All right, so this is kind of an overview of what I was just talking about. Now, because it is constantly firing, and because the medullary cardiovascular is constantly adjusting for blood pressure, the response is very, very rapid. It's very, very quickly. Usually within a beat or two of the heart pumping, and that coronary sinus, or I'm sorry, that carotid sinus detecting any kind of shift or change in the pulse or that pressure, it can go ahead again within 2 beats. It can have the blood pressure regulated and controlled. And so again, this is a very quick response system. All right. What are we talking about? Well, we're talking about here is if the carotid sinus, if the Barore receptors within the carotid sinus detects an increase in blood pressure, the Medullary Cardiovascular Control Center immediately sends out signals through the vagus nerve to stimulate parasympathetic response. And so what does that mean? Well, what that means is it's going to go ahead and stimulate the release of acetylcholine. Acetylcholine is going to slow down the electrical rhythm within the sinoatrial node to go ahead and decrease stroke volume, to decrease cardiac output, to go ahead and try to regulate the blood pressure that way. At the same time, it's also going to try to decrease sympathetic stimulation through the decrease of norepinephrine, which is going to lead to vasodilation. And so we reduce stroke volume, we reduce cardiac output, we initiate vasodilation, and the end result is lower blood pressure. But again, remember, has to happen very quickly. And the reason why it is coordinated and regulated through the Medullary Cardiovascular Control Center in conjunction with the autonomic nervous system is because as autonomic nervous system, with the utilization of neurotransmitters, we know that has a very rapid and localized response. Right? Whereas if it was using hormones through the endocrine system, it would not be as rapid of a regulation, because hormones, as you will discover as we move through the semester, hormones have a much slower response time. They're more widespread, there's less specificity, and there's a slower response. And so that's just not conducive when we're talking about something like blood pressure. You want a quick, immediate, fast response. And so parasympathetic is the way, and the sympathetic nervous systems are the way to do that. And so again, this is kind of what is happening here from a picture perspective. All right, so right here, all right, this here is in the aorta. All right, this one here would be in the common carotid. So these are your Barore receptors with those sinuses built in. Right? These guys are both now communicating with the Medullary Cardiovascular Control Center in the medulla oblongata. Right? Its job is to stimulate and regulate, maintain autonomic tone. Right? This balance between sympathetic and parasympathetic regulation. And so again, both of these are going to have an influence over the SA node, but the sympathetic is going to have direct regulation over your veins and your arterioles. Remember, parasympathetic only influences the heart. Parasympathetic does not regulate or influence vasodilation or vasoconstriction within the arterioles. That is the sole responsibility of the sympathetic nervous system through epinephrine and norepinephrine, and whether they're binding to beta receptors, which are found within the arterioles and the veins, or whether they're binding to alpha receptors, which are found within the capillary beds and the precapillary sphincters. Again, this is just another view of that. And so this is what we would define as being like almost like a little negative feedback map. All right. Nothing different on this as what you were just seeing. So in the scenario of increased blood pressure, the carotid sinuses are going to increase the firing of those Barore receptors. It's going to go to the cardiovascular control center, the Medullary cardiovascular control center. It's going to decrease the sympathetic output, less norepinephrine, which is going to lead to vasodilation within the arteries. It's going to lead to a decrease in the force of contraction within the myocardium. That's more so epinephrine. All right. Vasodilation reduces peripheral resistance. Decreased force of contraction is going to go ahead and decrease the cardiac output. Right. Decreased cardiac output, decreased peripheral resistance, decreases the blood pressure. All right. And you have this negative feedback right here. So that is the regulation that we are seeing overall. And with that, we have come to the end. And so congratulations. And keep studying, keep reviewing, keep those questions coming, and I'll catch you on the flip side.